Now let's take a look at question 1. Find each of the following. Calculate f prime of x, the derivative, using the definition. Okay. So when we use the definition to find the derivative, we need to keep in mind this formula that is very important. Limit h goes to 0, f of x plus h minus f of x divided by h. And we can remember it as the difference of the function divided by the difference of the input. On the top, you see that the input in the first bracket here, that is x plus h. And the second one, that is x, right? So it's kind of the difference of these two outputs, the difference of the function value. And in the bottom, this h can be viewed as the subtraction of x plus h and x, right? So this is essentially x plus h minus x. So once we think of that, we can just very easily remember this formula: difference of the value of the function divided by the difference of the input. And we also need to let the difference to be as small as possible. That's why we as h goes to 0 here. So after understanding this formula, let's do this question 1. F of x equal to x squared minus 3x plus 4, right? And by the definition, we have to plug in, right? So plug in, that is replace this x with x plus h. So this is this thing here is f of x plus h. And second thing here, this green thing, that is f of x. After plugging in, the rest of the stuff is just purely limit computation. We know how to do this type of a limit, right? So just open the bracket, right? Then we have a bunch of terms, right? And now we cancel this x squared and this x squared, right? And also cancel this 3x, right? This 3x here. Okay, cancelled, right? And also cancel this 4, and this 4 has been cancelled. After that, we come to this step. We are left with 2x plus h squared minus 3h on the top, right? And then we try to evaluate this limit. We know that the best option for us is to plug in. Well, in such a case, plugging in is never possible because you have h in the denominator while h approaches 0. So if you just plug in directly, you will always have 0 in your denominator, right? So that is that means we need to do some extra stuff, right? Factorization to cancel out the 0 factor, which we have covered in our last workshop. So just to factor out the h from the top expression here, right? This h is here. Factor this out. So you have h times this 2xh plus x plus h minus 3. And this h can be cancelled with the h in the bottom. So we cancel out the 0 factor. Now we're left with this expression, which has no more 0 factor. And we can plug in h equal to 0. And keep in mind that the limit is about h. So it's h that is going to 0, not x. And in this case, we treat x as a constant number. Okay, just plug in 0 into h. And the answer we get is 2x minus 3. So the derivative of this function is 2x minus 3. Once we got the answer, we can use the parallel rule to verify this answer. You can take the derivative of this, right, directly by the derivative rules and see if you can get the same expression. If your expression is not the same as the expression you got here by using the definition, that means you have something wrong in some steps in between. Okay, and it's very easy to verify that the derivative of this, that is by using this formula, parallel rule, right? That is n x n minus 1, right? So it's 2x minus 3, right? The 4 at the end, that is a constant. Derivative of any constant is 0, right? Just pay attention to that. So that is our question 1. Okay. Now let's move on to our question 2. That is a kind of a reciprocal function. 3 divided by x squared. But we will do it same way. Firstly, write out the formula. Always keep in mind this formula. Even though you don't know how to do the following, always write down the formula. You may be able to get some marks in your exam. And then we're gonna plug in this, replace the x with x plus h. So we got this difference of two fractions on the top expression divided by h. And since we don't want to have fractions inside the fraction, so we will need to turn this, kind of simplify this. We know that divided by a thing, it is equivalent to multiplying the reciprocal of this thing. So here, this expression, the top expression, it's dividing by h, which is equivalent to multiplying 1 over h. So now we turn this expression into this form, right? This difference multiply with 1 over h here. Now we continue to deal with this subtraction. This subtraction, we're gonna do the cross multiply, right? Multiply the denominator and cross multiply this, cross multiply that. So we have this common denominator being the product of these two denominators, right? Cross multiply gives you 3x squared in here, and 3 times this bracket square in here, right? Subtraction. And next step is obviously open the bracket. Okay, open the bracket, and see that this 3x squared, it's gonna cancel with this 3x squared, right? And just like that, right? Cancel out, and we are left with this 6 minus 6x h plus 3h squared on the top, right? We're left with this thing on the top. Well, they both have h as a factor, so we can factor out the h, right? Factor out the h here, and we're left with minus 6x plus 3x on the top. Right? But keep in mind that we also have this 1 over h outside, so this h cancel with the h on the top, so these two h's are gone, and finally we're left with only this expression, right? since we have cancelled out the zero factors, we can now just plug in without worrying too much. So plug in h equals 0, remember, not x, it's plugging into h. So we have minus xx plus 3 times 0 divided by something, and then it comes out that is negative 6 divided by x to the 3. And as before, we want to check whether this is the correct answer, so we can use the rule to verify this, right? So the rule to verify this, I'm gonna firstly rewrite this. This can be written as 2 times x to the negative 2 dividing by x squared is the same as multiplying x to the negative 2. Now by the rule, the power rule, right, this is equal to, we pull that exponent to the front to become coefficient, and then the new exponent is the previous exponent minus 1, so it's negative 2 comes out here, right? Oh, sorry, this is 3, not 2. So negative 2 comes out here times 3, right? X to the negative 3 is the previous exponent minus 1. And now this can be written as negative 6 times 1 over x to the 3, this guy, which is exactly the same as our answer found by using the definition. So now we have verified our answer. We can rest assured that this is correct, right? So we get full marks in exam. So that is our question 2. Now let's move on to question 3. We get some ugly square root, right? Always write out the formula first, okay, formula, and then plug in. Okay, wow, that is a gigantic expression. Plugging in here, this guy, right, is this guy. So we have seen such kind of limit before, square root minus square root. We know that we need to multiply the conjugate, so we're gonna multiply this conjugate here, right? Square root minus square root, whose conjugate is square root plus square root. Okay, multiply this conjugate here, and then we're gonna make use of the difference of square formula, which I will remind you here. That is a minus b times a plus b equal to a squared minus b squared. And the purpose of using this formula is that we want to use the square to cancel the square root. So the top expression here, the purple expression here, becomes a squared minus b squared, which is x plus h plus 5 square root bracket square minus this square. This is the purple expression here. And the square root cancel with the square, so we are left with this guy here. Now we can open the bracket, right? And for the denominator, we don't need to do anything. We just multiply them as a product of brackets. And we don't have to multiply them through yet. Just leave them there. Work on the top. Open the bracket. You see that this h, this x, I should say, cancel with this x, right? And this 5 cancel with this 5 when you open the bracket. So on the top, we are left with h solely, and this h can be cancelled with the factor h in our denominator. So now these two h's are gone. Cancel, cancel. So finally, we are left with this 1 over this expression. And since we have cancelled out the zero factors, we can just plug in h equal to 0. So we have 1 divided by this square root of x plus 5 plus x plus 5, and then that comes to twice of this x plus 5 square root. So that is the final answer. Okay. And as before, we can use the rule to check the answer, but that requires the chain rule, right? Since I want to cover the chain rule in the following, so I'm not checking this yet, since maybe some of you are not familiar with the chain rule yet, so I will leave it, save it after I finish the chain rule. Okay, so that is question 3. And move on to question 4. That is similar. Okay, this square root thing, right? Always write out the formula first and then plug in. Okay, and when you plug in, you can turn you need to turn that division into multiplication. That's 1 over h times this thing, just as before, right? Because it was like dividing by h. So now we work on this expression, this bracket, and cross multiply. Cross multiply, right? So we have this multiply with this, and this thing multiply with that. Okay. So that becomes this thing minus this thing on the top, right? That is square root minus square root. We are very familiar with this, as we did question 3, right? So what we need to do is to multiply the conjugate, right? This is the conjugate, square root plus square root. So multiply the conjugate, and in the same time factor out the 2 here, because we don't want it to be in our way, right? Factor it out, and then make use of the difference of square formula. That is a squared minus b squared. So it becomes this bracket minus this bracket, right? That's the top expression, because the square root cancel with the square. If you want to write them out, that is the a squared minus b squared. That is this expression here is equal to this square minus this square. Okay, and now the bottom, as before, we can just leave them here, not doing anything for now, until we cancel the zero factor. So we open the bracket on the top and see that this x cancel with this x, and the 2, this negative 2, cancel with that negative 2. So we are left with negative h on the top, right? This negative h, the h can be cancelled with the h in the bottom. And now the top expression is left with negative 1. So this becomes negative 1. Okay. Now this negative 1 multiplied with that 2 becomes negative 2. And now we have cancelled out the zero factor, right? We don't have to multiply through the bottom, which is a gigantic expression. we can just substitute h equal to 0 into this expression. So we will have this thing becomes 0, right? This thing becomes 0, substitute. So we have x minus 2 square root times x minus 2 square root, right? And times this twice of that, because this thing is x minus square root, x minus 2 square root plus x minus 2 square root. Is like two of these things combining together. So that's why it's 2 times square root of x minus 2, twice of this thing. Okay, and now we have 3 of this square root multiplying together, right? And the square root can be thought of something like 1/2 in the exponent. And we have 3 of them multiplying together. So we have these 3 things multiplying together. So that is x minus 2 to the 3/2. Okay? So that is x minus 2 to the 3/2 in the bottom. And that is our final answer. I should say cancel this 2. This 2 cancel with this 2. That's not very difficult to notice. So that is our question 4. It's relatively more complicated than the first 3 questions, right? You need to make use of the difference of square root for difference of square formula to get rid of the square root, and you also need to know multiplying the conjugate. That is the very common technique that we need to use. And a little summary about this type of questions. In these 4 questions, you may have seen the same step, which is the key element, the essential step here, is that we must cancel out the 0 factor. So in question 4, you see that these 2 h's, they got cancelled out, the 0 factors, right? And in question 3, these 2 h's cancel out because they're 0 factors, right? And question 2, these 2 things cancel out, right? 0 factors. Question 1, these 2 h's cancel out. So in this type of questions, using the definition to find the limit, you must know that the h in the bottom here, it must be cancelled out before you can plug in. That is the key element of this type of question. If you were not able to cancel out this h, that means there's something wrong. There must be something wrong in between in your steps. Okay, so that is our first question using the definition to find the derivative. Okay, so now let's move on to our second question, differentiation rules. We have a bunch of questions here, and I wanted to divide this questions into 2 parts. That is, the first part is from question 1 to question 6, because that has nothing to do with the chain rule, I believe. And then from starting from question 7, we need to work on the chain rule. So let's do the first 6 first, and after we will work on the chain rule, which is the most complicated part. Okay, so now starting with question 1 here. Where is question 1? Okay, so this one here. So we have a bunch of terms. So that is just the solution. Actually, question 1 is quite simple, right? So you have a bunch of terms here, right? And you can just take the derivative term by term. Okay, do it here. By using the parallel rule, right? For the first term, you pull this 7 here, right? That becomes coefficient. And the new power is the previous power minus 1. So it becomes this. And for the second term, this 4 goes down here. So it multiply with this 3, so you get 12 here. And the new power is the previous power minus 1, which is 3, right? 4 minus 1 is 3. And for the third term, we have exponential function. We know that the derivative of e to the x is e to the x itself. It does not change, right? So there's nothing to work on, right? That is 5x e to the x. And the next one here, this term, can be thought of as 2 times x to the negative 1, right? So this negative 1 goes down, multiply with that 2 there, so it becomes negative 2, right? Minus negative 2, so that is plus. Yeah, this is supposed to be plus here. The negative sign cancel with the negative sign before the 2 over x. And the new power is the previous power minus 1, so that is minus 2 power. So that is this term here. And for the last term, this is x to the 1 over 2, right? Pull this down to the front, and it becomes 1 over 2 here in the coefficient, and the new power is 1 over 2 minus 1, that's negative 1 over 2. So it should be very straightforward by applying the power rule. Okay, so that is our question 1. Now take a look at question 2. Question 2. Do that the same way. Pull this to the front, so 5 over 2 in the coefficient, and the new power is 5 over 2 minus 1, which is 3 over 2. Okay, that is this term. And the second term is 0 because e to the pi is a constant. We know that the derivative of any constant is equal to 0. Okay, that is simple. And the next term here is power rule. Pull this to the front, negative 3, multiply with 9, that is negative 27. And the new power is the minus 3 minus 1, that is minus 4, right, the new exponent. And the last term, we have this guy here. This pi is a coefficient, right, multiply with that 4. And we apply the power rule to pull this to the front, that is 4 pi times t to the 3, which is 4 minus 1. Okay, so it should be very straightforward. Question 2. Now let's move on to question 3. That is a little bit more complicated here. Question 3. It's a product of 2 functions. So we need to apply the product rules. So let me write it down for you. Product rule. Suppose we have 2 functions, f and g. And the derivative of this product is equal to derivative of the first one times the second one plus the first one times the derivative of the second one. okay? So it's gonna be, you know, the function f here is this guy, and the function g here is this guy. So by the product rule, we're gonna do derivative of f, which is this one, right, times g plus f times derivative of g, okay? And then for the derivative of f, we use the power rule as before to pull that to the front. So it becomes this 3x squared. And for the derivative of g, that is e to the x, is e to the x itself. And after that, this is the final answer. It's like combining the power rule and the product rule. Should not be too difficult to understand. Right. That is our question 3. Now question 4 should be also about product rule. This is the function f, this is function g, right? We're gonna do derivative of f, which is this guy here, right, times g plus f times derivative of g. So for the derivative of f, this 2 goes to the front, right, and minus 1, so it becomes 2x here. And this 4x, right, 4x, this power 1 goes to the front, right? So it's still 4, but the new power is 1 minus 1. So it's essentially x to the 0, which is just the identity 1. So that's why it's 2x plus 4 here. And the last term, that's 3, its derivative is 0 because 3 is a constant, okay? So it disappeared. For the derivative of g, same thing. This 5 goes to the front, so it becomes 25 here, right? And the next term, this 1 over 2 goes to the front, and new power becomes negative 1 over 2. Okay, so that is power rule and the product rule together. It should not be too complicated. Now let's come to question 5. That is a little bit different. This requires the quotient rule. Let me write down for you. Quotient rule. That is f over g derivative. It's equal to g squared in the bottom, and on the top we have f prime times g minus f times g prime. So in contrast to the previous formula, the quotient rule, the product rule, this sign is minus. Just pay attention to that, not plus. In the product rule, we have the plus sign, but in this, we have the minus sign here. Okay, so we're gonna make use of this formula. We have our f function, that is this one here. We have our g function, that is this one, right? And we know from the formula that the derivative should have the g squared in the bottom, which is here, g squared. And this guy here should be f prime, right? And this is g minus f times g prime. And to figure out f prime, we have oh, actually I wrote it wrong. F prime is this guy here. This is G. We can switch the order they multiply it. Actually does not matter, right? F prime times G is the same as F times G prime. F prime times G is same as G times F prime, because multiplication is commutative. And F prime is 12, 3x to the 3, because this 4 goes to the front, right? Multiply with the 3 becomes 12. And the new power is 4 minus 1, which is 3. Okay, should not be too complicated to figure out. And for G prime, that is the derivative of x squared minus 2x plus 3, right? That is G prime. It's also straightforward. And for the denominator, we don't have to do anything. Okay. And for this expression, maybe you're concerned about simplifying, but we don't worry about that, because for this type of question, the question wants to check whether you understand how to use those rules. So you don't have to simplify the expression. And leaving it in this form is easier for the marker to see your answer, because once you simplify it, the terms they mixed up and they combine and then become different forms, so it's more difficult for the marker to see. So that's why we never simplify our final answer when we got a question like this, unless we're gonna use this later on. Okay, so that is a clarification that we don't need to simplify the final answer in this type of question. Just leave it like that. Now moving on to question 6. It's the same thing, quotient rule. Function f over g. Right? This is f, and this is g. Okay. By the formula, we have f prime times g, right, minus f times g prime. Okay. And for f prime, this 2 over 3 goes to the front, right? It's here. And the new power is this minus 1, so that is negative 1 over 3 times g. And the second term, f times g prime. For g prime, we have cos of x. We know that the derivative of cos of x is negative sine of x. You just look up to the formula sheet. So that's why we have this thing here. And for the next term, that is 5 over 7. So this thing goes to the front. And then this new power is this minus 1. That is negative 2 divided by 7. Okay? And for the denominator, just the square of the function g. And that is already the final answer. We don't have to simplify anything, just leave it like that. So that is our question 6. Very straightforward, just by applying the quotient rule. Let's talk about the chain rule, starting from question 7. Here. So for this type of chain rule questions, when we use the chain rule, the most important thing is to identify the outer function and the inner function. So you need to know which function is applied in the most outside, which one is most inside, and how many functions are there in the entire composition. That is the first thing to know. Otherwise, you will find the chain rule very confusing. So now let's take a look at this function. This is h equal to t cubed plus 3t squared bracket to the 5. And we recognize the most outside function, that the function that is applied in the most outside is this power function. So now we can kind of decompose this h function into two separate functions, which is, I will let this h equal to y to the 5, while y it's equal to t to the 3 plus 3t squared. That being said, we introduce a variable in between h and t so that the relation becomes relatively easier to understand. And for both of these two functions, we know what their derivative is because we can apply those formulas from the formula sheet. That is why we decompose it this way. And now we just follow, after understanding this, we just follow the formula to find out the derivative. And I also want to emphasize that we set a derivative here. We have to understand with respect to which variable for the derivative. So this function is a function of t, right? So that when we talk about the derivative, it should be the derivative with respect to t. So we write dh dt. That means the derivative is with respect to t. And by the chain rule, we can kind of insert a variable in between. So this is equal to dh dt, dy times dy over dt. Right? Now this derivative, dh divided by dt, is the derivative of h with respect to y, not with respect to t. Which means when we look for the derivative, we should use the relation between h and y. Okay, and for the next one here, that is the derivative of y with respect to t. So we should be using the relation between y and t. Okay, so now let's do it. This green box is equal to dh dt, right? That is 5y to the 4. We just pull this thing down here, this power, right? With respect to y, so it's written in terms of y, right? And the next one, dy dt, we just apply the power rule again and the sum rule, so it becomes 3t squared plus 6t. That is the derivative of this one. This is y prime, right? Is equal to 3t squared plus 6t. This goes down here, this goes down here. And this h prime here is 5y to the 4. Just multiply them together. But after, we have to substitute the y back into this expression so that everything is written in terms of t. Because the variable y is the one that we introduce, right, is acting as a bridge. We don't actually need it in our final answer. So you will need to replace this y here with the original expression in terms of t. So it's written as 5 times y to the 4, which is t to the 3 plus 3t squared to the 4, right, times this 3t squared plus 6t. And that is how the chain rule works. We need to know which one is the most outside function, which one is the most inside. Otherwise, it will be very confusing. So that is our question 7. Now move on to the next one. Question 8. Same steps. Identify the most outside function and the most inside function. The most inside function here is this polynomial function, because when you plug in t in this expression, you compute this polynomial first before you compute the exponent. So that this is the most inside function, right? So we can write this as g equal to e to the y, right? While y is equal to t to the 3 minus 4t squared plus 2t minus 5. Kind of decompose it into 2 parts, right? And followed by the formula dg dt, right? That is the derivative of g with respect to t. By the chain rule, we have dg divided by dy times dy divided by this g. Let me write that clearer. dg divided by dt. Okay, this is g here. So for dy dg, we look at this expression, exponential function, right? So the derivative is just e to the y. And for the next one, that is dy dt, we look at this expression. That is the polynomial function, so it's 3t squared minus, this is 4t squared, right? 4t squared, so the 2 comes down and it becomes 8t and plus 2, right? Minus 0, 0, we don't have to write 0. So that is the derivative. And next step, we replace y with this expression. Is y here replaced with the expression. So we have e to this t3 minus 4t squared plus 2t minus 5 altogether times 3t squared minus 8t plus 2. Okay, that is the final answer. And you can see that it's not super difficult as long as you are able to identify the most outside function, most inside function. It's easy to understand. What may seem complicated is when the function is composed with many functions. And so far, the last 2 examples we have seen are just a composition of only 2 functions. And then when is mixed with another other stuff such as the product rule, sum rule, and some other things, it could be confusing. Okay, so now let's take a look at this more difficult question. Question 9, right? So it's a product of two functions. We will need to work on the product rule first, okay? And inside the product rule, there's another product rule here, right? So there is a product rule inside the product rule. And also, in another factor here, this one, we will need to apply the chain rule for this function. So let's work them out separately first. So the derivative of, firstly, this e to the 3x, it's equal to e to the 3x times 3. Because there's two functions here. The first one is this e to the x, right? So you need to view this thing as a whole thing, right? And this is your y, right? Y is equal to this green box. And this e to the 3x here is the derivative of this exponential function with respect to y. So that is the derivative of e to the y. That is why it's e to the 3x. And the other 3 here is the derivative of 3x with respect to x. So that is why this 3 comes out. And that is about the chain rule, okay? And now we apply the product rule first in this derivative. So y prime is equal to the derivative of this bracket times the other bracket plus this bracket times the derivative of the other bracket. And some of you may be wondering, why do we sometimes write the prime to indicate the derivative? Why do we sometimes write dy over dx or something else? And that is because when we use the chain rule, we want to understand for which the derivative is with respect to. In that case, we need to write d something over d something, just to indicate that what the derivative is relative to. But in this case, since we're not using the chain rule, or the chain rule is very obvious to see it here, we don't have to write out that expression. And also, when you're comfortable of using the chain rule directly, you don't have to write those intermediate steps, like letting y equal to something, letting u equal to something. You don't have to do that if you can just see the answer in your mind. Okay, so now moving on, I need to compute the derivative of this one here, right? So the derivative of this one, you apply the sum rule, that becomes the derivative of the first term plus the derivative of the second term. But the derivative of the first term here is a product of two functions, so we need to use the product rule for this single factor here, this orange thing here. that is the product rule again. Okay. Again. So it becomes the derivative of the first factor, that is x, so that is 1, right? Times the other factor, ex. And the plus x times the derivative of ex, which is ex itself, right? This one. That is the derivative we obtain by using the product rule. Then we write out the second factor. Its derivative is 50 x to the 9 because the 10 goes down and then multiply with the 5. Okay, so that is the derivative of the first bracket. And times e to the 3x. Now plus this bracket times the derivative of the other factor, which I have written here. That is the derivative of e to the 3x. So times e to the 3x times 3. Okay, then it's done. That is the final answer. We don't have to simplify the expression. Don't bother to multiply through the e to the 3x into the bracket. We don't have to do that. Just leave it like that. Okay, so that is the chain rule and the product rule together. And actually we use the product rule twice inside the product rule. Okay, so a little bit more complicated. And now moving on to the next one. Oh, this guy is interesting. Question 10. So we have the cosine function inside the sine function. That is the chain rule we have to use for this guy. And after that, there's another x to the 4 multiplied with this thing. So that is the product rule, right? So we clear that as product rule and chain rule. It's product, chain rule. So firstly, we will need to view this sine something, this gigantic expression, as a whole thing. And this whole thing is multiplying with x to the 4, right? And because of that, we need to use the product rule. So the derivative of hx here, h prime, it's equal to the derivative of x4 times this factor, this gigantic factor, and plus x to the 4 times the derivative of this one, okay, which will require the chain rule. Now let's write them out. The derivative of x to the 4 is 4x to the 3, obviously. This times sine of cosine of x, right? And plus x to the 4 times this. So for this step, we need to use the chain rule. Chain rule. So when we use it, we view this yellow expression here as a whole thing. And the most outside function is the sine function, right? We go from outside to the inside. That is the derivative of the first layer. We see that is the derivative of this sine function with respect to the inner function. That is y, right? Y equal to this, y equal to this one. But we try not to just write this every single time. Just do that in your mind. Imagine that this yellow expression is your y. So you're looking for the derivative of the sine y, right? That is cosine y. But now y is replaced by this expression. So it's cos x here. Okay? And this times the derivative of the inside function. That is the derivative of this cosine x, which is negative sine x. Okay? So that is the how we do it in our mind. You better be able to do it. If you think it's still complicated, then you can write out the expression like how we did that before, right? Right, this sine, this green, this orange thing here, that is z is equal to sine of y, right? Well, y is equal to cos of x, and this guy here is the derivative of z, dz divided by dx, right? And that, by the chain rule, is written as this dz divided by dy times this is dy divided by dx. Right? Dz dy, that is cos y, right? And dy dx, that is negative sine of x. But we don't want to do that every single time because we want to be more efficient. So try practice more until you're comfortable seeing this thing. And also this y, right, this here, should be replaced by this expression. That is why we have this cos of cos x here. I hope that is not too confusing. If it really is, no worry, we will go over some more expressions so that you will be more comfortable with this. So that is our question 10. Chain rule is complicated. Now moving on to 11. 11. It makes me reminds me about the Stranger Things. Now we have this. Sine to the 5 of this expression times cos of this expression, right? When we got this expression, we don't rush to find a derivative. We kind of firstly identify the most outside function and most inside function and what kind of rules we need to use. So what we see first is a product, right? This green box multiply with another green box here. Okay, so that is 2 factors. So the first step is use the product rule. That is the derivative of the first green box multiplied with the second one, right? times the second one here plus the first green box times the derivative of the second green box here. Okay, so that is the structure. Now we start to work on the derivative of each individual green box. For the first one here, this blue expression, we need to use the chain rule. So we identify the most outside function. What is the most outside function? It's not the sine function. It is the power function, the fifth power, because this is essentially sine of this to the 5. So actually this is a complicated expression. It has 3 functions composed together. So we need to start with the derivative of the most outside function. Okay. That is the fifth power. So to do that, we need to view this as a whole thing. This expression as a whole thing, right? And then we just drag that 5 down to be the coefficient, and the new power will become 4. Okay, so 5 here times this expression to the 4. Right, the 4 is written here. So that is just the derivative of the first layer, right? After we're done with the first layer, we move on to the second layer, and then we cross out this 5, right? We focus on this expression now. So that is the sine function, right? Which is the second layer. The second layer, right? Second layer, so we will view this function inside as a whole thing, just like sine of a capital X, sine of something. Its derivative is cosine, right? So it's cosine of this thing. Okay, so now we finish the second layer. Now we cross out this, finish it, and move on to the last layer, that is the polynomial function, and its derivative is easy, right? Just drag that 2 down, multiply with 4, so it's 8x plus 3. Now you see that this derivative needs the chain rule, and it's written as product of 3 things because it's composed with 3 different functions. So when we do use the product rule, we go from the outside to the inside, just step by step to work out this derivative. Okay, and after that we need to multiply with the original cos 3x plus 2, right? That is just the first term of our entire derivative. We need to plus this sine 5 4x2 plus 3x, multiply with the second guy here, and and also requires the chain rule. Okay, the inner function is this 3x plus 2. So we take the derivative of the outside function first. That's the cos of x, right? So cos of x, its derivative is negative sine of x. But now the x is replaced with the inner function, right? The inner function here, 3x plus 2, right? And this is just the first layer, the derivative of the first layer. We need to multiply the derivative of the inner function. That is the derivative of 3x plus 2, right? That is 3. Right? So we have 3 here. Okay, so now we finish all the derivative. So this is the final answer. You see that is super complicated, but we don't need to simplify it. Okay, that is our question 11. Now let's move on to question 12. Firstly, identify the most outside function, which is the square root, right? So the derivative of f of x is equal to, let me write this first so that is not too confusing. To the 1 over 2. So the most outside function is the 1 over 2, right? So when we view this as a whole thing and take the derivative, we apply the power rule, just like x to the 1 over 2. And its derivative is 1 over 2 times x to the negative 1 over 2. But now the x here is replaced with the inner function, so fill this in with the inner function. Okay, now we finished the first layer, the derivative of the first layer, so we cross it out. Okay, cross it out, but just, pretend that just cross this out in your mind. Don't actually cross this out in your exam, because this is the expression of the f of x, right? Maybe you can do that in your scrap paper, but don't actually do it here. I'm crossing it out just for educational purposes. And now we take a look at this derivative of the second layer. That is the sum, right? The sum of these two functions. So it becomes the derivative of this green thing plus the derivative of this blue thing. For the derivative of the green thing, we need to apply the chain rule, because the 7x is acting like the inner function. So we view this as a whole thing, right? Derivative of the exponential function is exponential function itself. So set e to the x, right? But the x here now is replaced by the inner function 7x. That is just the first layer times, right? We need the times the second layer. That is the derivative of this 7x, which is 7. So it has another 7 here, right? Now this is the green expression, and plus the derivative of the second term, that is 45 x to the 8. Okay, and this simple. Okay, now we finish this derivative. We go from outside to the inside to find out. We use the chain rule to find out the derivative of each layer, and there is another chain rule inside the chain rule, so we actually apply the chain rule twice. That is question.